AI security is entering a new era, and the story is bigger than one product launch, one model, or one vendor announcement. The important shift is that artificial intelligence is beginning to change the tempo of cybersecurity. It changes how vulnerabilities are found. It changes how security operations centers evaluate alerts. It changes how attackers scale phishing, reconnaissance, and social engineering. And it changes what defenders have to do if they want to keep up. This briefing focuses on 3 signals from the current AI security landscape. First, Anthropic's Project Glasswing and the idea that frontier models can be used to find high-severity software flaws before attackers do. Second, the reality check from security operations. Many SOCs are experimenting with AI, but only a small minority report excellent value. Third, the operational pressure created by AI-driven threats, where speed and coordination may matter as much as the quality of any individual tool. Let's start with Project Glasswing. Anthropic describes it as an initiative to secure critical software for the AI era. The company says it is working with major partners across cloud, software, security, finance, and open source, including names such as AWS, Microsoft, NVIDIA, Google, Cisco, CrowdStrike, Palo Alto Networks, Apple, JP Morgan Chase, and the Linux Foundation. The goal is defensive: use advanced AI to help identify and fix vulnerabilities in systems that matter. The claim that makes this important is not simply that AI can help write code. That is already familiar. The claim is that an unreleased frontier model called Claude Mythos Preview has reached a level of cyber capability where it can identify high-severity vulnerabilities at a scale that changes the defender's timeline. Anthropic says the model has found thousands of high-severity vulnerabilities, including issues across major operating systems and web browsers. The company also says it does not plan to make that model generally available. That last point matters. If a model can help defenders find latent vulnerabilities in critical software, it can also help attackers if the same capability is released without strong controls. This is the dual-use problem at the center of AI security. The same capability that can find a bug for a maintainer can help an adversary search for a bug in a target. The same code reasoning that helps secure software can also compress the time required to discover, weaponize, and operationalize flaws. For defenders, the opportunity is real. If trusted security teams can use AI to find severe vulnerabilities earlier, the patching window improves. Open source maintainers may get help reviewing complex code. Browser vendors, operating system teams, cloud providers, and security researchers may be able to scale analysis across codebases that are too large for manual review alone. In the best case, AI gives defenders a way to reduce the backlog of hidden risk. But the risk is just as real. Vulnerability management is already difficult for most organizations. Many teams struggle to move from advisory, to prioritization, to patch testing, to deployment, to verification. If AI accelerates vulnerability discovery faster than organizations can patch, the result is not automatically better security. It could be a larger pile of urgent findings, more noise, and a narrower window before attackers adapt. This is why AI security cannot be treated as a demo. It has to become an operational discipline. The question is not only whether an AI system can find a flaw. The question is whether the organization can validate the finding, understand exploitability, assign ownership, patch safely, measure exposure, and confirm that the issue is closed. Without that workflow, even accurate AI findings can become another source of pressure. That brings us to the second signal, the security operations reality check. A Hacker News report highlights that only 10% of security operations centers say they are getting excellent value from AI. Whether that number changes over time or not, the message is useful. Many organizations bought into the promise of AI for security, but the first wave has not automatically solved alert fatigue, investigation quality, or response speed. There are several reasons for that. Security data is messy. Alerts are incomplete. Identity context is spread across systems. Asset ownership is often unclear. Many organizations do not have clean playbooks for the human process, so adding an AI assistant does not magically create a mature workflow. If an analyst has to check 5 consoles, ask 3 teams, and manually correlate incomplete data, an AI layer may help summarize information, but it cannot fully fix the underlying fragmentation. There is also a validation problem. AI can produce confident analysis that still needs checking. In security, false confidence is dangerous. A tool that summarizes an incident incorrectly can waste time. A tool that recommends containment without enough context can disrupt business. A tool that labels a finding as low risk because it misses identity or exposure context can leave an attacker path open. This is why AI in the SOC needs guardrails, measurement, and human accountability. The practical direction is clear. Security teams should define where AI is allowed to act, where it is allowed to recommend, and where it must only summarize. They should map AI tools and agents to human owners. They should log actions, preserve investigation context, and validate automated findings before high-impact response steps. They should measure outcomes such as time to triage, time to containment, false positive reduction, and analyst workload. AI value should be proven by operational metrics, not by a vendor demo. The third signal is attack speed. Bleeping Computer's June 11 coverage on AI-driven threats argues that artificial intelligence is increasing the speed and scale of cybercrime in ways traditional security operations were not designed to handle. The point is not that every attacker is using a science fiction autonomous agent. The point is more practical. AI can help generate phishing content faster, improve social engineering quality, accelerate reconnaissance, and make repetitive attacker tasks cheaper. That pressure is especially important for managed service providers and enterprise teams with fragmented security stacks. Many environments still separate endpoint detection, remote monitoring, patch management, backup verification, identity controls, and incident reporting into different systems. During a real incident, those seams matter. An alert appears in one console. Patch state lives in another. Backup integrity has to be checked somewhere else. Containment may require a different tool. Reporting may be manual. Every handoff creates delay. In an AI-driven threat environment, delay is expensive. If attackers can generate convincing lures in minutes, test variations, automate reconnaissance, and move quickly after initial access, then defenders cannot rely on slow manual coordination. Detection alone is not enough. The defensive loop has to connect detection, containment, recovery, and communication. The winning teams will not be the teams with the most dashboards. They will be the teams with the shortest reliable path from signal to action. This does not mean every organization needs to buy a massive new platform tomorrow. It means they need to reduce operational friction. Start with the basics. Know which systems are internet-facing. Know which identities have privileged access. Know which backups are usable. Know who owns each critical application. Know which alerts require immediate containment and which require investigation. Then use AI carefully to speed up the steps that are already defined. For executives, the message is that AI security is not just a tooling budget category. It is a risk management issue. If AI models can find vulnerabilities faster, boards need to ask how fast the company can patch. If AI can improve phishing, leaders need to ask whether employees, identity controls, and detection workflows are ready for better social engineering. If AI is being deployed internally, leaders need to know who owns those agents, what data they can access, and how their actions are audited. For technical teams, the message is more concrete. Inventory AI systems and shadow AI usage. Treat AI agents as identities, not as harmless scripts. Apply least privilege. Keep humans accountable for high-impact changes. Validate AI-generated security findings before acting on them. Use AI to summarize logs, draft investigation notes, compare advisories, and speed up routine analysis, but do not let it silently make critical decisions without review. For vulnerability teams, the priority is triage quality. AI-discovered issues may arrive with impressive technical detail, but organizations still need to ask, is the affected component deployed here? Is it exposed? Is authentication required? Is exploit code available? Is there evidence of exploitation? Is there a compensating control? What breaks if we patch immediately? Those questions are not old-fashioned. They are the bridge between a model finding and a safe security decision. For SOC teams, the priority is workflow. AI should reduce cognitive load, not increase it. A useful AI system should help an analyst understand what happened, what assets are involved, what identity context matters, what similar incidents exist, and what response path is recommended. But the system also needs to show its sources, preserve uncertainty, and make escalation easy. If analysts cannot trust or verify the output, the tool becomes another alert stream. For MSPs, the priority is coordination. Clients do not care how many consoles a provider uses. They care whether threats are detected, contained, recovered, and explained. AI-driven attack speed makes fragmented operations more painful. The more automated the attacker workflow becomes, the more important it is for defenders to have connected containment and recovery steps. So what should organizations do this quarter? First, create an AI security inventory. List approved AI tools, unofficial AI usage, AI agents, integrations, owners, data access, and logging. Second, choose 2 or 3 SOC workflows where AI can safely help, such as alert summarization, phishing analysis, or advisory comparison. Third, strengthen vulnerability response for internet-facing and identity-related systems. Fourth, test incident response with a scenario that includes AI-assisted phishing or AI-accelerated reconnaissance. Fifth, review whether backups, endpoint isolation, identity controls, and communication channels actually work together during a crisis. The most important point is that AI will not replace cybersecurity fundamentals. It will amplify the difference between teams that execute fundamentals quickly and teams that execute them slowly. Asset inventory, identity control, patch management, logging, backup recovery, incident response, and user awareness still matter. AI simply raises the speed requirement. Project Glasswing shows the defensive promise. Frontier AI may help find serious vulnerabilities before attackers exploit them. The SOC value gap shows the implementation challenge. AI only helps when it is connected to real workflows and measured outcomes. AI-driven threat speed shows the strategic pressure. Attackers can move faster, so defenders must reduce friction. This is the new AI security equation. Better models are coming. Better attacker automation is coming. Better defensive automation is also possible. The organizations that win will not be the ones that treat AI as magic. They will be the ones that govern it, measure it, integrate it, and use it to shorten the time between knowing there is a risk and actually reducing that risk.